Investigators at the U.S. Department of Agriculture wish to compare methods of determining the level of E. coli bacteria contamination in beef. Two different methods, A and B, of determining the level of contamination were used on each of 10 randomly selected specimens of a certain type of beef. The data obtained in millimicrobes per liter of ground beef for each of the methods are shown in the table below. You can see that in this table we have the specimen number 1 through 10. We have then the method A and B, and then the data values that resulted from each specimen and each method of testing. Is there a significant difference in the mean amount of E. coli bacteria detected by the two methods for this type of beef? Provide a statistical justification to support your answer. And this problem actually did appear on an AP exam, and the idea behind this problem is for the test taker to demonstrate that they can differentiate between sets of data that are independent and sets of data that are dependent. Now, because we have one sample generating two data values, we have what is called a dependent situation. We have dependent data sets because we have one subject generating two data values. In other words, this particular specimen, specimen 1, generated a value from test A and from test B. And then again, specimen 2 generated a data value from test A and generated a data value from test B. And those values generated by those different methods will depend on the condition of the particular specimen in each case. So they are dependent. So what we're going to want to do then is conduct a paired t-test. And we'll do it then by matching those pairs. This is also called a matched pair test. A matched pairs test. Now when we do this, we'll be using a t-test. So we will need to find a critical value. And since this is a two-tailed test, and we know that it's a two-tailed test because we're asked, is there a significant difference? We're not asked if one of these particular methods generates a value that is greater than the other. So since that's the case, then we are going to have a two-tailed test. And then if we choose alpha to be 0.05, that's going to put 0.025 in each tail. So we'll have two critical values here, a positive one and a negative one. Also, right here in the middle then will be our hypothesized mean difference. Now notice we're using a capital mu to indicate population mean, but then we have a little subscript of a d, which means then the mean of the differences, because when we do this particular test, we're going to find some differences. And when we do that, we're going to want to decide on an orientation, whether it's A minus B or B minus A. It doesn't matter. We just have to be consistent all the way through the problem. So our null hypothesis will be that the mean difference is 0, and since this is a two-tailed test, the alternative hypothesis should be that the mean difference is not 0. If we choose A minus B, then this value here would be 22.7 minus 23, or minus 0.3. And then we'll have 23.6 minus 23.1, or 0.5, and on down. Now we can generate these by hand. These are not particularly difficult numbers to come up with, but sometimes we might be in a situation where the numbers are a bit more difficult to work with. And fortunately, the TI 83 and 84 calculators will do this very nicely. we've jumped a little bit ahead of ourselves. Something that we need to do is establish our critical values. And we can use the TI-83 or 84 calculator to do that. We can do that by going to Second, Variables, and go to 4, Inverse T. In the upper area, we should have 0.975 since alpha is 0.05, and we've separated this out into two tails. We have 10 subjects, and the number of degrees of freedom will be n minus 1, one less than the number of pairs, so that'll be 9. Come down and hit paste. And then if we're using a TI-83 or 84 calculator that does not use the menu to generate these values, we will use this syntax where the appropriate order is the area, the accumulated area, and the number of degrees of freedom. Close your parentheses and hit enter, and we come up with a T critical value of 2.262 if we round to 3 decimal places. So we'll have 2.262 in the upper tail and minus 2.262 in the lower tail. Now, we need to generate then a t-test value. And that t-test value we can generate very easily using the TI-83 or 84 calculator. In order to do that, we'll need to put the data values in a list. And so we'll push stat and then 1 for edit. Now I have already put these data values in these lists, list 1 and list 2. I put the A's in list 1 and the B's in list 2. Now what I want is for the calculator to generate the differences for me. And it'll do this very easily. I'll go up here and highlight L3. And what I want it to do in L3 is subtract list 2 from list 1. So we'll hit second L1 minus second L2. Hit enter. And now it has placed all of those values that we started to generate on our own in this list. Now I want to find the t-test value associated with these values. So we'll hit stat, go over to tests, 2 for t-test. Now it's going to ask me, are you going to tell me some data or some statistics? Well, we have data in a list, and as a matter of fact, it's in list 3. Now our hypothesized mean is 0. We'll come down here to where it says list, and we'll hit second 3 so that it now says L3. We'll leave this frequency at 1. Now we want to get this alternative hypothesis correct. So we want it to say not equal to, since it's a two-tailed test. And then we'll hit calculate. And we see that we have a t-test value of 1.456 if we round to 3 decimal places. Also note that our p-value is 0.1793. Now we need to make a decision. And if we use our test value paired with our critical values, or our p-value paired with our alpha value, it doesn't matter. We're reaching the same conclusion either way. Notice that our test value does not land in the rejection region. It lands here before we actually hit that point of rejection. So our conclusion would be do not reject the null hypothesis. If we use the p-value and alpha, we arrive at the same conclusion. Since the p-value is not less than alpha, we should not reject the null hypothesis. So our conclusion then should be something like sufficient evidence was not gathered at the 0.05 level of significance to conclude that a difference exists in the mean amount of E. coli bacteria detected by the 2 methods for this type of beef.